Next up is Kyung-Tak Lee from Samsung. Kyung-Tak is a technical leader of mobile communications service standards at Samsung and has led the OMA Communications Working Group as chairman since 2007. Kyung-Tak has been an active participant in OMA since 2004, and prior to his role as chairman of the OMA Com Group, he assumed also the roles of chairman of the OMA MWG MMS Sub-Working Group and vice chairman of the OMA Messaging Working Group. Kyung-Tak has in-depth expertise in many areas relating to messaging and communication, including MMS, mobile email, and converged IP messaging. He's been actively involved in various industry associations and standardization organizations, including GSMA and ITUT. Prior to joining Samsung, he worked at Motorola in the areas of automatic speech and handwriting technologies. So, welcome, Kyung-Tak. I'll just pull up your presentation.
Good morning, everyone. So it's an honor for me as the chairman of the OMA Communications Working Group to present you today the history of OMS messaging work from MMS to converged IP messaging. So during this presentation, what I'm going to present you is first an overview of OMA messaging history and a description of the previous OMA messaging activities that happened, including MMS, mobile email, instant messaging, and converged IP messaging. I also go through, take this opportunity also to provide you a few number of current activities that are going on to OMA Communications in order to provide you what are the next steps that we are preparing, and also an example of application of OMA communication enablers in the market. So you can see here an overview of OMA messaging history. So you can see that the OMA communication has been involved since the beginning of OMA, so from 2002, and it's been now more than 10 years now that we have been involved in these activities. But so if you see now the evolution, that we can separate this evolution in three different steps or categories. The first, from the beginning of creation of OMA, we spent time from inheriting. We first inherited, because OMA has been received inheritance of a few numbers of enablers from existing the previous forums, such as the Web Forum or the Wireless Village forums, where we inherited these enablers and also developed and enhanced the user experience from these. So we have the MMS, multimedia messaging services, and the instant messaging and presence service, IMPS, where we developed from the different version up to 1.3 versions for each. After that came some new initiatives, especially due to the emergence of 3G networks and IP-based network and SIP-based networks. So there's been initiatives such as involving the instant messaging based on SIP and simple networks. So simple IM, instant messaging based on simple, and also initiative to provide the mobility to existing services and enablers, such as the email for mobile devices, so mobile email. And nowadays, so we are most focusing now on two main aspects. First is convergence. So we have so far been involved with different services and user experiences. Now all these experiences start overlapping and converging. So it is the goal of the OMA Communications to provide some new and novel enablers that try to converge these different experiences into a single enabler into the market. So one of the most representative is the converged IP messaging. And coming with the convergence came also the maturity of the different enablers coming into the market, and OMA Communications, OMA has been also put a lot of effort now to support the different go-to-market initiatives, and one of the most representative one is RCS, Rich Communication Suite. I'll come back a bit later. So starting with the past, now I'm going to just through quick overview of the past different enablers that OMA Communications were involved. One of the first is the multimedia messaging service that provides conformance and interoperability of MMS related products and services. And here, the main activity of the communication is to provide some interoperability between the different devices, and since there are many different codecs, many different possibilities of exchanging MMS. So the MMS activities were focused on providing some tables of that make interoperable, and setting some different classes of MMS services, such as for MMS for images, basic image, rich image, video, basic video rich classes, and for which the different devices that support the different classes could interoperate with each other. There has been also of course, the usual some usual different services, such as providing person-to-person, also group communication, group messaging based on MMS. But also MMS was not just only used for just transporting MMS, but it could be also used as a transport for more high-level value-added services. It could be a game. For instance, during a game, you could use, for instance, MMS to provide some text multimedia messaging between people, between gamers, between different game game users. Providing also a template in order to facilitate the creation of MMS. And also, as you know, the MMS is not just about the sending of multimedia, but also how you layer the different multimedia components, such as audio, video, and text, audio. And so it was also the activities was also focused on usage of SMAR and CMF, that's different formats, in order to lay out how you lay out the different the multimedia components, as in the picture you can see, such as putting the display of text and pictures on the left side, and putting, for instance, put a text, or you have a spoken sound while you're displaying the multimedia. So next came the mobile email. So, you know, of course, email is quite well known standardization, but the focus of this activity was to provide an end-to-end standardization for email service, but adapted especially to mobile environments. So what it means is that you have, for instance, you can see here on the below picture the architecture of mobile email. So all the blue side, on the right side, you can see the standard email server that you would use to correspond the emails based on the traditional email services. But then this architecture has been enhanced to provide email for mobile environment, which consists of mobile email client server and outbound notifications. So in terms of features, you can get, for instance, be able for the client, even if you're not connected to the mobile email service, being able to get outbound notifications whenever, for instance, a message arrives, and being able to then to connect at that point in time. Being able also to set preferences on which kind of messages that you would like to get notifications from. Just, it could be new messages, but it could be also, for instance, based on priorities of your message. Exchanging of client capability information, since, as you know, mobile devices have different capabilities in terms of hardware or software, and also the mobile clients and can support different types of protocols. So based on that, you can also decide to receive or not, and how to and when you would like to receive it and you need to adapt to your device, how to, for instance, transcode the different content that you receive. It could be in terms of character set, text, image, audio, video. And this activity has been a good example of collaborations between OMA and other fora, other initiatives in email, such as the Lemonade Working Group in IETF, that provided the IMAP SMTP binding for the mobile email, and OMA DS group, for which we also had collaborated a lot to provide a DS binding for the mobile email service. Then also we have instant messaging. So as mentioned, we first generated the instant messaging from the Wireless Village Forum, so for which we provided enhancements. And around that, so after that, we came the simple IM, so based on SIP and simple, in order to leverage the progress of the emerging 3G networks and networks over IMS or MMD, and there was different activities that were going on at that time, such as the development of SIP simple protocol in IETF, or the activities for instant messaging in both in 3GPP and 3GPP2. So it was the goal at that time, so to provide an instant messaging that can encompass and coordinate, consolidate and coordinate the different instant messaging activities of the different fora into providing, doing a gap analysis of the different requirements existing in different fora, and providing an architecture that is agnostic to the underlying network, which could be IMS, it could be MMD, it could be any other type of networks. So it was mainly a lot of coordination also between the OMA and the different fora that were involved in the instant messaging. And some of the features, of course, there are some features that you probably know well of now. Is, for instance, probably the pager mode, just a simple one-shot messages, providing a session mode where you can first establish connection with the different users you would like to talk to, establishing closure, but you can also modify your sessions based on the media you would like to exchange in the middle. Joining a public session, conference session, participating control, you can add or remove, sending a large text or multimedia text, also file transfers, different messaging, also being able to store your messages in a conversation as a conversation history. So after that, after all these different types of messaging came a point where we felt that there is need for converging all these different user experiences. So you can see that the limitations of the messaging services such as MMS, IM, they all developed in different parts of the history, and they were developed in I would say silos. And as you can see in the figure on the left, is that you have different experiences, different services such as SMS, MMS, IM, push-to-talk, or email provide some user experiences, but also user experiences that overlap with each other, such as pushing for SMS, pulling for MMS, but you can have also sessions, but that you can find the different user experiences across the different services. You can see for the media, when you talk about media, SMS is basically text, but when you look at MMS, is multimedia. IM started with text, but also evolved with more multimedia exchanges between users. Push-to-talk as well started with voice, but became more also multimedia, exchange of multimedia between users, and same for email. So you could get across the different services an overlap of the different medias that you can get, an overlap of the different user experiences, and also on the networks. So this CPM converged IP messaging was motivated by converging the different experiences and to define an IP-based framework with capability to provide user experiences from existing communication services and provide a global architecture that can interact with existing messaging services, because the plan was not just to provide a new service that is not interoperable cannot interact with the existing ones. So a lot of effort has been done also on the interworking aspects, and so also leveraging the capability of SIP IP networks such as IMS. So if you see now some of the main features of CPM 1.0, so the CPM 1.0 has defined the concept of CPM conversations, in which CPM conversation is constituted of any arbitrary number of standalone messages, of session, or file transfers. And inside the session, you can have the chat messages, and you can exchange any type of multimedia, such as voice or video. And so once you have this CPM conversation in place, so what you can do about it? So you can, for instance, exchange that between users, of course, but also when the users have multiple devices, such as it could be mobile phone, it could be tablets, it could be notebooks. So when you have this messaging, for example, a message or a chat invitations that arrives, on which device you would like to receive this kind of messages or notifications, so you can decide on that. It provides also a message storage for any types of this data, which it is just a single message or session or entire CPM conversation history. Also, it provides also the interworking. So converged IP messaging can interwork with existing SMS, MMS, or email, so provide the capabilities for that. But one of the goals also of CPM is also to provide the capabilities for the sending user not to be aware as much as possible of what kind of messaging service the recipient is capable of. So when a CPM user would send a message, as much as possible, he would not be aware, he does not need to be aware of whether the recipient is a CPM user or an SMS, you only support SMS or MMS. So the interworking decision, whether you need to interwork and to which kind of service you need to interwork, will be taken care of by the network itself. So which provide a better user experience for the user, for which the user had to know so far what kind of service you had to deal with when your friends support, for instance, CPM or other type of services. And also, finally, also user preferences that is applied to all these type of services, whether you want to receive, so on which devices you want to receive a message, or whether you want to interwork or not a message when it arrives to you, and for instance, when you're roaming or not, you may prefer to receive it via interworking rather than a full multimedia message. Or also whether on preferences, you can also set preferences on storage, whether which types of media you would like to, which type of messages you would like to store or not. So now I come to some current activities, briefly to some current activities of OMA communication. So what are the current activities we are doing to provide you a little bit of an evolution of what you've been doing from the past. So we are now working on Simple IM 2.0 and Converged Messaging 2.0. And the main goal of this is to support the GSMA RCS initiative related work by adding missing the functionalities to support the functionalities that are requested by RCS E 1.2 and RCS Release 5. So some of the features is to provide such as display and deliver notifications for also not only outside of session but also for chat messages. Storing forward functionality for not only messages but also notifications. Enhanced multi-device functionality for chat. Fixed chat groups, also file transfer, such as being able to get a thumbnail of the file before it gets actually transferred, or being able to resume a file transfer when it is interrupted. Supporting also for live recording for chat messages. And so Simple IM 2.0 is about to become candidate this month, so quite soon. And CPM 2.0 is now under development and is scheduled for May of next year. There is also work on enhanced visual voicemail, so to provide some common mechanism, interoperable mechanism to provide enhanced voicemail service, which builds on work on OMTP VVM 1.3. Some of the features, of course there are many, but some of the features that have been put here is, for instance, from elaborated greeting management, such as providing different types of greetings based on the time of the day or the caller ID. Some default VM delivery decide on when you would like to provide this voicemail, at what time of the what date. You may not want to provide the voicemail immediately, but at a later point in time. Enhanced voicemail features such as setting a background audio for your voicemail, rich contents, emotion indications, recording, and also being able to provide all that in a multi-device environment for whatever devices you have. You are able to support the enhanced visual voicemail service. So, and candidate approval is set for soon, so this month. So it's also about to become candidate. Communication is not just about just messaging, but also how you start a messaging service or communication service. In many cases, users use the address books as a landing pad for different types of communications. So but the goal of this initiative in OMA, in Converged Address Book, is that there are different types of address book that exist nowadays, which could be device-based, or it could be SIM-based, it could be service-based, or ISP offered, or dependent on the different types. So the goal of this is to develop a network address book that allows use of a single and common address book for all types of devices, SIM or services. So, and provide also advanced features which aiming at enhancing functionality and user experience in the address book. So you can have some of the features that are shown here is that you have a single network address book for all the types of devices. When you have your address book in the network, you're able to automatically also update based on what the changes you make on your address book, being able to update to other users' address book as well. being able to automatically receive based on the subscription that you make to other address, to the network address book of the other users, being able to automatically receive updates from other users. Number 4, also search or publish contacts on the phone directory, search sharing contacts, sharing some of your contacts with other users, importing, exporting contacts, profile from other address books, and some more recent activities in the Converged address book area is also focusing a little bit on enriching the few features with contacts with social network users, being able to interact with social networks, and for instance, being able to get information about suggestions of contacts from, for instance, from different users in social networks and story suggestions. Last is a recent activity that has started in OMA communication is immersive social communication. Here the goal is, okay, so far it has been mainly communications between person to person. So now the focus is expanding this communication aspect in order to how to integrate the viewing experience when you view, for instance, watch TV or show or sports events and so on. And you like also at the same time being able to communicate with others. So how to provide a service level framework to enable a full integration between the content viewing experience and your communication experience, and this in an immersive and multi-device environment. So being able to, for instance, when you're watching TV, being able to communicate with your friends at the same time, being able to know what kind of event he or she watches, being able to really get through your devices additional information about what you see at the same time, such as filmography, reads photos, or on the right side on the picture, being able, for instance, to follow what your friend is watching and being able to synchronize your view, what you're watching with what your friend is watching. So being able to get the same view at the same time. So yeah, this has just been started, and the candidate approval is scheduled for January 2014. And so an application of OMA communication labels in the market. So I just put the most representative, and which is a RCS, Rich Communication Suite, which is a collaborative effort as far as the introduction of commercial IMS-based rich communication service. As you can see, so in the figure, this is just a release 1. I believe the next speakers will provide more information about that. We can see that already from RCS release 1, we have been some of our enablers such as OMA Presence, XDM, or SimpleIM have been involved from the start for providing some of the main features of RCS, such as the in-house messaging, or for chat, or file transfer as well, and presence, and other features for RCS. So this, I believe, I expect next speakers will be provide you a bit more information about that. So if you have more information, if you'd like to get more information, this is the coordinates of the different chairmen of the OMA communication, so we'd be happy to provide you more help on that. Okay, thank you very much.
Okay. Thank you very much, Kyung Tak. So I think I picked up from that OMA has a significant heritage in messaging, particularly in MMS, and also has quite a bit of heritage in terms of consolidating and coordinating instant messaging and other types of messaging systems and pulling those together. So are there any questions for Kyung Tak from the floor? Dean?
Yeah, okay. Use the microphone or just...
Yeah, if you could use the microphone.
Hi, Dean Bubley. I'm curious about the assumption of the value of convergence and why you think it is always good to combine contacts, say, into a single address book. Do you not perceive that there may be social value to the user of having separate address books? Personally, I wouldn't want to combine my LinkedIn contacts with Facebook, with my Twitter followers, with my phone contacts. Why do you assume otherwise?
I think depends on the usage that you like to do. Of course, maybe the examples you provide, maybe it depends on the usage. Of course, you may want to separate your contacts from here and there. Here, the concept of converged address book, for instance, is being able to provide a network-based address book for which you are able to share this across multiple devices, for instance. Because when you are, for instance, managing your contacts on one device, you do not want to have a different also. If you like to get the same information on a different device, you do not want to have you need to have different local address book that you have to manage at different for each of these devices. So the converged address book, it provides the facility for the user to also to be able to manage that in a more easily way.
Okay. So I would say that one of the important things about the converged address book is that it provides the facility. Now different implementations in phones can give users different options. So if you don't have this facility, you can't do it. Once you've got the facility in the phone, you can choose to use it in one way or in a different way. So for some users, it might make more sense to have 2 or 3 address books, one of which is a merger of several. And you can do that with this facility. If we don't have a facility, then you're stuck with managing multiple address books.
Talk about it later, I think. We've got a panel session at the end of the day.
Okay, thank you. If there's no more questions, perhaps we should move on. Thank you very much, Kyung Tak.